Right, now it's time to take a look at one of those types that we had on the previous page, and here's what we had before, and that's the generic type, and here's one of the more unpleasant types I generated on the other page, and the question is, what exactly do we understand by that, apart from it being pretty awful. Hopefully you'll never see anything quite as bad as this, but if you have to, this is how you have to go about analysing it. Right, well, let's take a look at it. We've got Gn of something or other which is super this thing here. So, the first question to be asked is, what are the supertypes of this thing? And that's what we do first. So, let's have a look at the supertypes of this. Well, for a start, we can do n of something which extends Q of b. It is its own supertype, so that's a start. And what about Q of b? Are there any supertypes for that? Well, the answer is yes, there is L of t. Q of b, so we got L of b. So we can put that in as a supertype. What about, can we go any further? We've got L of b there. A, B, and C are going to be supertypes, so we can have n of something that extends A, n of something that extends B, and n of something that extends C. So that's all nice and easy. Have we got anything else? Well, yeah, there's n of the wildcard form, of course, which is going to be a supertype of all that lot. Right, is there any other approach we can take? Well, we've got n there. N of something, one of the supertypes can be L of the same thing, so we can put all that lot down again with L in front. Now that's all valid, and if we've got L of something, A, B, and C of course are supertypes, so we can have those in too. Right, is there anywhere else we can go? Well, yeah, if we take a look at this thing here, L of B, there are two fairly obvious supertypes of that, which are L of something that extends B and L of something which is super B, will both give L of B as a subtype. So we can have that straight away. Well, now we've got super B, we start going in the other direction. To get supertypes, now we go down the tree on the last element there. So we've got B, we can go L of something, and that will be a supertype of the one above. If we got L of something, we can go N, and if we've got L of something, we can also go Q of the same thing, so we can go like that. And again, there's a fairly obvious supertype for all of this, which is going to be L of the wildcard. And we could go further, of course. We can then set to work on that, and well, it gets worse and worse. Or we could do the same exercise with Q of B as well, and we could do it here and here too. But I won't go through all of that. We just move to the next stage, I think. Right, the next stage is to remove those types we generated down here which violate the type bound. Right, the type bound is L of something which extends B. So, what about this? Is that a subtype of it? Well, N is certainly a subtype of L, and Q of B is certainly a subtype of B. Q of anything is going to be a subtype of B, because it extends LT, and LT is certainly a subtype of B. So, yes, that is indeed a subtype. Similarly, N of something which extends L of B for the same sort of reason is also going to be a subtype of that. But if you come to something like that, that is not a subtype, because A is not a subtype of B. So we can rule that one out. Similarly, we can rule that one out. What about N of the wildcard form? Well, that is certainly not a subtype. It's got N of various things in here, like object for a start. N of object, well, that's certainly not going to be a subtype of that. So you can forget it. This is a super type of this lot. It's certainly not. Being a super type of that, for instance, it's got that in it. And that certainly hasn't got that in it. So you can rule that one out. What about this? Well, basically it's the same sort of pattern. You can rule out the A and the C and the wildcard form as well. And we can also automatically rule those out because they're certainly not going to be subtypes of that, because they've not got anything to do with L. So what we're left with is the all this lot, by the way, remains. What we're left with is the actual types, which are if we put GN in front of them, okay, you get the types which are for the whole load of types, and you can set this to those types. Right, it's a pretty ugly looking thing, but that's what it does. Okay, so GN of anything which we've got left there, give all possible types assignable to this type in question. Now, that's difficult enough, but believe it or not, you could make it even more difficult quite easily, because only GN here has got a type bound. You could have had type bounds on Q and on N and on L as well, and it'd get even worse. In general, my advice is that although you might be able to understand things like this, don't ever write them, because you can bet that no one else will understand them. And my advice generally is, I suppose, to, if you can, avoid writing your own generic types. If you take a look at the generic types which are in the collections framework, with all the lists and maps and sets and so on. The generics which are used in there are kept nice and simple. There's nothing complicated about them, and they're easy to use. If you go start putting lots of complex bounds and conditions on things, rapidly things become really hard and complex, and they get in the way, and they're more trouble than they're worth. So my advice is, don't write generic types if you can avoid it. If you've got to write them, keep them really simple. Nice simple types. Don't have bounds if you can avoid it, and if you can't avoid it, keep them as simple as possible. Don't have multiple bounds, because let's face it, if the compiler writers have managed to get wrong and not to get bugs in the compiler with multiple bounds with super, then what's that saying? Because it's saying to me that those sort of things are not well understood. And if they're not well understood by the compiler writers, then they're not going to be well understood by your average programmer, so avoid it.